One.
Hello, fellow classmates, and welcome back to an awesome Team Teach. We will be covering Chapter 10 today. And ladies, I have a question for you today.
What is that?
What did the professor say when his parrot went missing?
I don't know what.
What did he say?
Gone.
Oh.
All right, everybody. Well, I'm Jasmine Rodriguez.
I'm Claudia Kemp.
I'm Jessica Johnson.
I'm Cece Rodriguez.
And we are ready to start this Team Teach.
Jessica, will the bucket overflow if we add a mouthful, a jigger, a jack, a jill, a cup, a pint, a bottle, a quart, or a gallon?
Cece, I'm so glad you asked that question.
Wait, what is a jack and a jill?
I know, right?
And what is a jigger?
I'm not sure, but it doesn't have the moves like Jagger. Cece, you would think that after we added all these things into the bucket that it would overflow, but it won't. And let me show you. We will actually have room left over for one more mouthful. A gallon fills the bucket up halfway. A bottle will take up half of the bucket this way. A quart will take up half of what's left over. A bottle will take up half of what's left over. And a pint will take up what's left over, half of what's left over. And a jill will take half of what's left over. And Jasmine, can you guess what's going to happen next?
Jessica, I think a jack will take up half of the space that was left.
You nailed it. That's right. And a jigger takes up half of what's left over. And then a mouthful will take half of what's left over. And guess what? We have room for one more mouthful, and our bucket never overflowed.
Jasmine, how many mouthfuls are in a quart?
Claudia, great question, and there is going to be quite a few steps, so take a seat. We will first begin by finding out how many mouthfuls are in a jill, in a cup, and in a pint. Once we do so, this will allow us to determine the number of mouthfuls in a quart. First, based on the information given, we can determine that if one jigger is equal to 2 mouthfuls, then 2 jiggers must be 4 mouthfuls, which is equal to 1 jack. So that means that 2 jacks are equal to 8 mouthfuls. So 1 jill is 8 mouthfuls. Next, we want to know how many mouthfuls are in a cup. Well, we just determined that there are 8 mouthfuls in a jill. So all we will do is double the number of jills to 2, which will also double the number of mouthfuls to 16. So 1 cup is equal to 16 mouthfuls. Third, we want to know how many mouthfuls are in a pint. Well, once again, we have determined that 1 cup is equal to 16 mouthfuls. That means that if we double it to 2 cups, that will be 32 mouthfuls. So 1 pint is equal to 32 mouthfuls. And lastly, if we just determined that 1 pint is 32 mouthfuls, we will once again double the number of pints to 2, which will also double the number of mouthfuls to 64. Therefore, 1 quart is equal to 64 mouthfuls.
Gotcha.
Jessica, how can we find the area of this square?
Jasmine, thank you for asking that question. I've been waiting all night for somebody to ask this question. The way I see it, I can show you or I can teach you. I'm going to let you have control of my computer, and I want you to place the little purple squares into the big blue square. Give me one moment. Okay, Jasmine, you should have control of my computer now.
Awesome. There we go.
Each purple square is 1 square inch. A unit is a form of measurement. A unit has an established amount used to determine a size to allow for comparison. Like we're doing here. We're comparing the smaller purple squares to the larger blue square. And each one of the squares is 1 inch.
Awesome.
Jasmine? Now then, Jasmine, if you look along the left side of the square, how many purple squares do we have?
It looks like there's 3.
You're correct. So this side is 3 inches. Jasmine, how many purple squares do we have along the top?
I believe we have 3 as well.
Yes, so the blue square has an area of 9 inches squared. And if you counted each square, you realize that they're each 1 inch equaling 9.
Thank you for that visual.
You're welcome. Can you tell me what the radius of a circle is, Cece?
Well, of course, Jessica, that's a great question. Here we see that a circle is inside the square. We know that the side of the square is 10 units, which is the purple arrow pointing to, and it is given to us. Therefore, since we're trying to figure out the radius of the circle, we divide 10 by 2, giving us 5 units. Therefore, the radius is 5 units.
Thank you, Cece.
How do I find the radius of the larger circle, Jessica?
Claudia, as Cece mentioned earlier, the radius of the smaller circle is 5 units. The larger circle will have a radius the same length as half the diagonal of the square. Here's the diagonal of the square. And we need to use the Pythagorean theorem to find the radius.
But you only said half of the diagonal.
Yes, so we only need to use this portion of the diagonal. The Pythagorean theorem looks like this. A squared plus b squared equals c squared. C squared will always be the hypotenuse of a right triangle. Take 5 units, which is one leg of the triangle, square it, plus 5 units of the other leg of the triangle, and square it, and we'll get the radius of 50. 25 plus 25 equals 50.
Jasmine, how would I find the missing length of the right triangle?
Cece, excellent question. Let me tell you, it is a lot easier than what you think. And since we already have the values of the 2 sides of our right triangle given to us, which is 6 inches and 8 inches, we will be able to use our handy-dandy Pythagorean theorem, which Jessica just talked about. Once again, the Pythagorean theorem is a squared plus b squared is equal to c squared. Our a squared and our b squared are going to be these 2 sides of our triangle. And for those sides, it does not matter which value we use, which means I could use 6 for a or I could use 6 for b. However, the value for c squared will always be the hypotenuse, which is the side opposite from our right angle. And all we do is plug into our formula, and we get that c is equal to 10 inches.
Jessica, can you explain to me what perimeter means and how I can find perimeter in the given figure?
Cece, yes, that is a great question to ask. Perimeter means the sum of the outside of a closed figure, such as this figure. However, if we were talking about circles, the perimeter is called the circumference. Based on what you just learned, Cece, how would you figure the perimeter of this figure?
Jessica, we will need to take 3 inches plus 3 inches plus 12 inches plus 3 inches plus 15 inches plus 5 inches, right?
Yes, you are correct. And we would get a total of 41 inches. This figure has a perimeter of 41 inches.
Thank you.
You're welcome.
Now, Jessica, how do I find the perimeter of this triangle?
Jasmine, based on what we discussed earlier about perimeter, how do you think you would find the perimeter of the triangle?
I think I would take the sum of all the outer edges of the triangle to find the perimeter.
Jasmine, good job. You would take 48.0 meters plus 69.0 meters plus 82.3 meters to equal 199.3 meters for the perimeter.
Cece, can you tell me which of the following has 32 mouthfuls, a cup, a gill, or a pint?
Yes, I will be more than happy to tell you which has 32 mouthfuls. The answer is a pint, as is shown of the pint of the milk of the given picture.
Jasmine, what are the different types of shapes in the figure, and can you tell me the formulas to use to find their area?
Yes, Jessica, of course I can. First, there are going to be 2 circles in this figure. We'll go ahead and just use one circle for the purpose of this question. In order to find the area of a circle, we will use the formula pi r squared, where r is going to represent our radius of the circle, which is the same thing as half of its diameter. Next, we also see that we have a square. And in order to determine the area of a square, we will use the formula a squared. A represents the sides of our square. And to find the area of the figure, you simply add up all of the areas of each individual figure.
That makes sense. Thank you.
Cece, I'm curious for you to explain to me, how do I find the perimeter of this triangle?
Great question, Jasmine. As you can see on your right, you see a picture that has perimeter that is shown in area. Let's take a look at an example. Let's say we're taking a walk around a fence. To find the perimeter, we walk around the fence, and to find the area is us walking inside is what takes up the space. So in this occasion, we use 88.8 inches plus 96.2 inches plus 37.0 inches, because we're taking the measurements of the outside of the triangle, giving us a total of 222 inches for the perimeter, Jasmine.
Thank you. I'm getting the hang of this perimeter thing.
Hey, Jessica, how do I find the volume of a sphere?
Claudia, buckle up because this was going to be a long ride. In order
Okay.
to find the volume of a sphere, you need to use the formula of 4/3 times pi times radius cubed.
But how do you come up with this formula to figure the volume of a sphere?
That's a good question. Let me explain. Imagine if you broke the sphere down into tiny pyramids to make up the surface area of the sphere. So these pyramids are making up the whole sphere. The length of the pyramids will equal the radius of the sphere. To find the volume of a pyramid, it's 1/3 times area of base times height. Since the height of the pyramids are the radius of the sphere, we change the height to radius. Change the formula to look like this. 1/3 times base 1 radius plus base 2 radius plus base 3 radius, etc. To find the volume of the sphere, you have to add all of the bases of the pyramid together, but we don't know how many pyramids we have. So we will have to use algebra to factor out the 1/3 and the radius.
I could imagine all the pyramids lined up in a row.
Yes, you're correct. You're getting the hang of this. When we factor out 1/3, we get 1/3 times base 1r plus base 2r plus base 3r. When we factor out the radius, we get 3 times base 1 plus base 2 plus base 3. Take the sphere and break it down into 4 circles, because when you take the circumference, the surface area of the sphere is equal to each circumference of the circles. This is where the formula of 4 times pi times radius squared comes in. Each circle uses the formula of pi times radius squared. You combine them together and you get 4 pi radius squared. Replace the formula we used earlier of r/3 times base 1 base 2 plus base 2 plus base 3 to r/3 times 4 pi r squared. Then we need to rearrange the formula to look like this. 4/3 times pi times r cubed. Because we combine the radiuses, we get r cubed. And I hope this helps explain why we use 4/3 times pi times radius cubed to find the volume of a sphere.
It sure does. Thank you for that. Now, Cece, can you tell me how many cones does it take to fill up the cylinder?
Well, of course, Jasmine. I like the way you're thinking. Let's take a look at this picture. Let's take a look at the next slide, which gives us a picture of a cylinder, a sphere, and a cone. It takes 1 cone to fill up the red part, and it takes 2 cones to fill up the sphere, and it takes 3 cones to fill up the cylinder, giving us a 1:2:3 ratio. So we are asked in the previous slide, How many cones does it take to fill up the cylinder? Therefore, the answer is 3.
Jessica, how would I find the area of a triangle?
Claudia, that is such a great question. When we are finding the area of a triangle, we use the formula of area equals 1/2 times base times height.
Now, where is the base and the height in this triangle?
Good question, Jasmine. The base is 82.3 meters. And the altitude is 41.0 meters. Altitude is the height of a triangle. Altitude of a triangle is a line that extends from one vertex of the triangle and is perpendicular to the opposite side of the triangle.
So Jessica, all we need to do now is plug in our values into the area formula?
You're absolutely right, Cece. Take 1/2 times 82.3 meters times 41.0 meters with a total of 1,687.15 meters squared. So, Claudia, how can we find the area of the triangle Cece mentioned earlier in our discussion of perimeter?
That is a great question, Jessica. Let's apply what we just learned. We remember that the formula for area is different for different shapes, but for a triangle, it's simple, as you just showed us. The triangle that Cece showed us, however, has a height of 8 meters and a base of 15 meters. We need these to determine the area of a triangle. Next is to plug them into the formula. And the formula for the area of a triangle is 1/2 base times height. Jessica, using the given triangle, what would the formula be to find the area?
1/2 times 15 times 8.
That is correct. So using this example, it would be 1/2 times 15 times 8. You would then solve and find that the area is 60 meters squared.
Thank you, Claudia.
Cece, can you tell me the name of the figure above?
Well, of course, Claudia. This figure is called a right triangular prism. We are asked to find the base and the height. Since this is a 3D figure, if we were to flip it and look at it this way, we can tell that the height is 8 meters, and therefore the base would be 15 meters.
Okay, Jasmine, looking at this figure, can you identify the different shapes and provide the formulas to find their areas?
Claudia, I sure can, but there is a lot going on here, so let me clear this up for you a little bit.
Thank you.
First, we have a right cylinder. To find the volume of a cylinder, we will use our formula B times H, where B is going to represent the area of the base of the cylinder, and H is going to represent the height of the cylinder. Next, we also see that we have a right circular cone. To determine the volume of the right circular cone, we use the formula 2 pi r cubed, where r is going to represent our radius of the cone. Lastly, we have a beautiful sphere. To find the volume of the sphere, we use the formula 4/3 pi r cubed. Once again, r is going to be the radius of the sphere. And to find the total volume of the figure, you simply add up all 3 of the volumes.
Claudia, we know how to find the area of a triangle, a sphere, and a circle, and a cone. What about the area of a circle?
That is a great question, Cece. As we all may have noticed now, there is no one-size-fits-all equation for finding area. I will use this figure from the homework to explain. The area of a circle is defined as pi times r squared, r being the radius. The inner circle is 10 meters across. Therefore, the radius of the circle is 5 meters. The formula then becomes pi times 5 squared. Cece, what is 5 squared?
25.
Perfect. Multiply that by pi, and we find that the area of this small circle here in units of pi is 25 pi.
Jasmine, how do you determine that this figure is a trapezoid prism?
Great question, and I have an answer for you. First, let me tell you that a trapezoid prism is a 3-dimensional solid. Of course, the 3-dimensional part is defined by the prism. It consists of 2 congruent trapezoids, one for its top base, and then one for its bottom base. So we have a trapezoid on the top and one on the bottom. It also has 4 rectangles that connect the corresponding sides of the 2 faces. These faces are also referred to as the lateral faces of the prism. As we can see, we have the first rectangular face on the top, then we have the second rectangular face on the side. We will have our third face, which is on the bottom, which I know is a little bit hard to see, but I know you have a great imagination. And then we have our fourth one on the side.
Thank you, Jasmine.
You're welcome. Now, Jessica, how do you find the surface area of a right trapezoidal prism?
Jasmine, I'm so glad you asked this question because this is one of my favorite problems to figure out.
Oh, is that great, Jessica? Teach away.
Okay, Jasmine, first find the area of one of the bases of the prism by using B equals 1/2 times A plus B times H.
Wait, where do I find A and B at in a right trapezoidal prism?
Claudia, that's a very good question. A and B represents the top and bottom of the prism, and we will need to add them together. Notice on our figure that 12 centimeters sits higher and 26 centimeters sits lower on the figure. A can be 26 centimeters and B can be 12 centimeters, or they can be vice versa. Now plug into the numbers into our formula and we get 1/2 times 26 plus 17, 12, with a total of 258 centimeters squared. Now we need to find the perimeter by adding all the sides together. Perimeter is 26 plus 12 plus 17 plus 15, which equals 70 centimeters. We use the formula of SA equals 2B plus PH. To find the surface area of a perimeter, the formula now looks like this. SA equals 2 times 258 plus 70 times 4, because now our height is here where the 4 centimeters is located. Because B is the area of the base of the prism, P is the perimeter, and H is the height this way where the 4 centimeters is. Surface area equals 796 centimeters squared. Cece, can you tell me how to find the surface area of this figure?
Of course, Jessica, that is a great question. So we know that the surface area formula is pi r squared plus 2 pi times r times h. So the formula that we're going to be using is pi r squared plus pi times r times s plus pi times radius times the height. So we're going to plug in our numbers that is given to us on the right side, which gives us pi times 2 times r squared plus pi times 2 times 6 meters plus 2 times pi times 2, giving us a total of 176 meters square for our surface area of this figure.
Thank you, Cece.
Hey, Claudia, how would you find the volume of a shape similar to the one that Cece just showed us?
Great question, Jasmine. That volume concept can be a little difficult to grasp. So here we have a figure similar to the one CC used with slightly different dimensions. In order to find the volume, we will use this equation here. R is the radius of the base, which is 2 meters. H1 is the height of the cylinder, which is 12 meters. And H2 is the height of the cone, which sadly is not measured for us. The height of the cone is found using the Pythagorean theorem like so. Okay, solve and we find that the height of the cone is 5.66 meters. Now that we have found all of our variables, we plug them in and get this final equation here. Solve and we find that the volume is 174 meters cubed.
Jessica, how do we find the volume of the capsule?
I'm so glad you asked because this looks very scary to find the volume of this thing. Really, it isn't too scary because we can break it down into different shapes. A sphere, 2 semicircles on the end, when we put them together, and a cylinder, which is in the middle. To find the volume of the capsule, we will use the formula of V equals 4/3 pi r cubed plus pi r cubed, squared, times the height. We plug in our numbers, and then we're going to solve. And we get 1,324 foot cubed.
Claudia, how would we find the surface area of this capsule?
Ooh, that's a good one. As Jessica said earlier, we can split the capsule into two pieces, a sphere with the two halves and a cylinder with the body of the capsule. The surface area of a sphere is 4 times pi r squared. The equation for the surface area of a cylinder is 2 times pi times radius times height. Okay, in this case, the radius, or r, is 4 because it is half of 8. The height in this case is 21 feet, and since we are finding the surface area of the whole capsule and not just a piece, the surface area is the sum of these two equations here. We plug in our values for the variables, solve, and we find that the surface area of this capsule is 728.85 feet squared.
Jasmine, can you explain the difference between the surface area and the volume of this shape?
Jessica, of course I can. I know we've done a lot of talk about surface area and volume, and let me explain another easy way to determine what the difference is. Let's begin with surface area. Surface area in our figure would be the amount of space that covers the outside of our three-dimensional shape. In order to calculate the surface area, we add up all the areas of all the faces of the shape. Surface area is always going to be measured in square units. Now think about a can of soup. The surface area would be the amount of aluminum that it takes to make the can. Next, we have volume, which refers to the amount of space inside of our 3D shape. Volume is always going to be measured in cubic units. Once again, let's go back to our can of soup, which is making me hungry. The volume would be the amount of soup that the can can actually hold.
Makes sense.
Thank you. That makes a lot of sense. Thank you.
All right, Claudia. We have gone over triangles a lot in this section. Can you explain one more time how to find the area of this triangle?
I sure can, Jasmine. We've seen one similar to this, but I'm going to use it anyways. Can anyone remember the formula used to find the area of a triangle?
I know. It's 1/2 base times height.
Good job, Jessica. The formula for the area of a triangle is 1/2 times base times height. This formula only calls for 2 different variables, but this triangle gives us 4 different measurements. As Jessica said, we only need the base and the height. So we would solve it like so. And we find that the area of the triangle is, almost needs a drum roll.
That's right.
1,654.35 meters squared.
Thank you.
Okay, Claudia. So we know how to find the area. How would we find the perimeter of the triangle with so many given measurements?
That is also a great question, Cece. There are times when our math books may try to trip us up by giving us too many numbers, as we've seen before, and being able to determine what is relevant and what is not is a very critical thinking skill. So we remember what perimeter is, right?
Yes, we do. It is the sum of all the sides.
Good job, Jasmine. The perimeter is only the sum of the sides, which for a triangle would be how many sides, Jessica?
3.
Perfect. There are only 3 values needed. One of these values is not a side. Can anybody tell me which one?
I think I can.
Which one?
I think it's the 41.0 meters, the altitude.
Yes, that one is not a side. It's merely just the height of the triangle. So 4.1 is not, or 41.0 is not needed to find the perimeter. Now we merely add up all of the other sides and we find the perimeter is 199.7 meters.
Awesome.
Great.
Thank you for listening to our team teach, guys, about length, area, and volume.
Thank you.
Thanks.
Bye.
Bye.